So listen, ma. We are going to start see about all these protocols. This is the network layer protocols. So IPV4, IPV6, and ARP, RARP, IGMP, ICMP. Among that, IPV4 and IPV6 are very, very important. So IP, from the name IP, we can say it's an internet network protocol. Okay. And ICMP, IGMP are nothing but internet control message protocol. And this is internet group message protocol. You all understand that along with the TCP IP model, this we say that this IP protocol is nothing but our logical addressing. And this ICMP and IGMP, mainly it will control the error message, and it is used for unicasting and multicasting. Unicasting means what? One-to-one casting. Multicasting means one-to-many. Broadcasting means one-to-all. That we used to say. So then ARP, Address Resolution Protocol, RARP, Reverse Address Resolution Protocol. So this is mainly to get the physical address and the internet address. We will see one by one. Okay. So today we are mainly going to cover the IP, Internet Protocol, IPv4 and IPv6. Okay. I think ma'am gave about the introduction about the addressing and that. So here we are saying that internet protocol means it's a unique internet portal address, which is recognized by the device on the internet or local area network where I can connect with my internet group. So I have IPv4 and IPv6. So in that, when you see to that, this will be 32-bit and that will be 128 bytes. We will use to say that. But while we are discussing in detail, all this network address protocols have a network node and a network component and a node component. That is also already defined. So this address classes, how we can divide the network and node component. Network ID, node component, host component, everything will be present in this address. Okay. Now we all know that a data link layer, transport layer, this IPv4 and IPv6 will be used. So this I told you that this is the main difference in terms of length of the address. First, we will see the detailed about IPv4. Then we move on to the IPv6. So here you see that is a 32-bit address, and this is 128-bit IP address. So we can say that the deployment here, which is varied in 1981 and 1990. So here we get 2 power 32. 4.3 billion addresses there, and here 2 power 128 IP address, 7.9 into 10 power 28. So this is nothing but we can do all kind of reused and masked, all things will be there. But here, because of this much of address can occupy, we can go with the unique address for each and every devices. So this is a decimal notation. I think we will see to that kind of configuration. This is a decimal notation and this is alphanumeric hexadecimal notation. Manish, register number 54. You want to sit and listen? You will sit and listen. So first you understand that it's a 32-bit and this is 128-bit address. Now we all know how we are getting this IP address. This is IA and A. We all know internet service provider will give the address, but that will be controlled by IANA, that is Internet Assigned Number Authority. We all know that we have a OSI model and TCP IP model, whatever be the model, we are following all the regulations and all. So the same thing, Internet Assigned Number Authority only, how the routers has to identify the numbers and what are the primary address, what are the secondary address, everything will be decided and it is controlled by IANA. So Internet Assigned Number Authority. Okay. Now, which is not in that area means that is automatically, you can see some of the satellite phones and all, we cannot able to capture the IP address now. That is all will becomes under the band. Okay, so if you are on in the regulation, we are supposed to follow this IANA. So all our IP address has to be come under this IANA, where it is a ISP, the Internet Service Provider. For example, any kind of service provider like Airtel, Jio, Reliance, and all, they will tie up with this IANA, and they, you all know, Indian Telecommunication Unit, above that IANA, then ISP, then our own IP address. So we have all a regulature. Under that only we are getting our IP address. Okay. So this is your binary key. How my datagram is transferring. Okay. So when you see my destination, it's not directly delivering my packet. So it is given to one router and from one router to the corresponding. So students, first we will see the IPv4 header. Okay. Then we will move on to that. I will complete this topic. Then I will explain the IPv4. So we all know IPv4 address. How many bit ma? How many bit address it is? How many bit address ma? Students, it's how many bit address?
32-bit.
Yeah, 32-bit address. Okay, it's a 32-bit address. So in a binary, we all know it can be represented in zeros and ones. So you all know this is 8 bits, this is 8 bits, this is 8 bit, and this is 8 bit. Okay, and while I'm writing my 8888 bit, while I'm writing my IP address in decimal form, how we are writing? That's very, very important. You just take it thus. This is the first 8 bit. This is the second octave, that is second 8 bits. And this is a third 8 bit. And this is a fourth 8 bit. I put dot over from first, second, third, and fourth. Okay. Now IP address. You just take the first 8 bit. In the first 8 bit, how I am writing 85 now? We all know that 64 plus 16 plus 4 plus 1. So what is the value? 64 plus 16, we all know how to convert that. 70, 80, 84, 85. When I'm seeing that 0, 1, 0, 1, 0, 1, 0, 1 means what? 5. Okay, 1, 0, 1, 1, 1, 1 means except 64, we have to add all the values. I get 191. And here I can simply say that this is a 1. So this is my IP address in decimal form. So you know how we are converting. There is a 32 bits are there. We are separating 8888 bits. So 4 8 bits will 4 octates we used to say. In that 4 octet, we combine the first octet, we get the decimal form of that. Then second octet, third octet, fourth octet. Okay. Now, kindly tell me this IP address, ma. Kindly tell me. This is in a binary form. You kindly tell me. Convert and tell me quickly. Convert this and tell me. Put it over the chat also. So I think I will give you 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. So that we may write down the values that 1, 2, 4, 8, 16, 32, 64, and 128. So 1, 2, 4, 8, 16, 32, 64, 128. Now you tell me the value, ma'am.
Sir.
Yeah, convert and tell. 128 plus 64, the first one. Because then while I am going with that, 128 and this is 32. 128 plus 30. Yeah. Anyone try it and tell me the answer, ma'am? No one. 128 and this is nothing but 32 and this is nothing but 8. So when I am finding my address, hello, when I'm finding my address, this is my value. Okay, 192, 168, 21, 76. This is the equivalent hexadecimal notation. So IPv4 32-bit address, how I have to write it in binary, and from the binary, we all know how to write it in decimal. So, and you all know this all separated by the dotted notation. Yes. Okay, each number is a byte. Byte, why we are saying na 8-bit is 1 byte. Okay, have you understand? Have you understand this? Yeah, kindly responded, ma. Students?
Yes, ma'am.
Yes, okay. So in this IPv4, how we were writing? 192.168.21 point something. Okay, now in your laptop or mobile, this is the procedure to see the IP bit address. Okay, when you see that, go to your start settings. In that network and internet you have, in that Wi-Fi, you click on the properties, definitely you can get it. Okay, this is for my house IP address. Okay, when you go with that, now if I share here the system, okay, can you able to view this? Can you able to see this? Here, if I click on this local area connection, so here you see IPv6 no internet access, IPv4 connectivity is internet, and this and all gives our speed as well as the duration, how long I am enabled and all. And when I go to the adapter settings, but here when I click on this, I have all this IPv4, IPv6 internet protocol and all. Okay, broadband connection, I will go, properties, network, and IPv4. Okay, actually we have obtained that domain name servers automatically. Here it is not there. So in that C colon also, when you go and type ipconfig, then automatically you will get your LAN. But this is the older system, and you all know it is connected by one LAN, and we have a control over the server, so we cannot able to view. But normally in your own system, it is a single user system. You can able to view the IP of the system. Is clear? Yeah, I think this is, I gave you that. My IPv4 actually in my 192.168.1.8. Okay, and in that, when you see that my network band, everything is there. So even my Mbps, that is in how that will be megabit per second. And this is a physical address, physical layer address, MAC address is also given. So when you connected to the proper internet, and we are under the control of IANA, or else we are under the control of ISP, Internet Service Provider, this IP address can be viewed and it is controlled by others. Okay. Now I told you how to represent this IPv4 32-bit address, and how to we have to write it in decimal form and all. Now we will see what is this IPv4 header, what is the information about that 32 bits. You all understand that how that 32 bits now, the 16-bit version, header length, type of service, and the total length is 16 bits. Okay, and we will see to that this is our IPv4 header. You all know Bluetooth we have a header file, and when you go with the Wi-Fi we have a header. Similarly, each and every protocol have a header file according to the header file only. And you all know this header file, what we studied separately, that thing will be embedded that one. So when you go with that, my data padding will be also there. So while we see that IPv4 header, how the 32-bit we are configuring, this is the first way. Then identification and fragments, and this is for fragmentation only. This is time to live, how long my packet has to live, and protocol and header checksum. And this is source IP address, destination IP address. So this is the IPv4 header. You all see version of the IP protocol. First, this version, I'm saying the abbreviation for each and every bits. So here when you go with version, that is the, while you are explaining the IPv4 protocol in your answer sheet, definitely you have to start with IPv4 header, then only you have to explain. IPv4, we all know it's a 32-bit and how we are representing it normally in that. But when you go with the explanation of the header files, you are supposed to explain with that version. Header length, we all having that header length is 4 bits. So when you see that, which is the number of 32-bit, 4-bit which they are allocating for the header length, and type of service. So low delay, high throughput, reliability, everything will be given in the type of service. You all know in the routing, we have seen to that, it always look up for the minimum cost, we said that. So how long the delay is there, how the throughput is there, what the minimum cost, it is considering the minimum hop less delay, all these factors also incorporated, so that it is identified in the type of service. And total length, okay, total length, we have told you that length of the header, that 20 bytes to 65,535 bytes. We all know data is 16 bits now, 2 power 16. This is nothing but 64 KB. That will be the value. The next one is, so when you see the version, header, type of service, total length, that we have the total length 2 power 16, that is 65,000. Then when you go for this another header, in that same header, identification, unique packet ID for identifying the group of fragments. Actually, when you know, this is the fragments, you all understand. Fragment means what? My entire data packet will be 2 size now. Automatically, it will be divided into small segments that we used to say as a fragment. You just see how the fragment 00 to 4000 means how it is dividing. How it is dividing 0, 175, 30, 350. In this way, you see this is my original datagram. And while dividing my datagram, it have a 3 fragments. And in particularly in the 3 fragments, I can divide my fragment 2 into fragment 2.1, fragment 2.2. So this is the fragmentation. So in that fragmentation, whether I have to split my datagram or not, that will be decided by the fragment offset. And I told you time to live, that is very important in routing protocols and all. The lifetime of the packets and how long it will be there, because while I am sending my packets from one router to another router, so how many hops it will be taken, how many loop it is passing. So the lifetime of the time to live of protocol is also very important. And there are so many bits are there for throughput, for low delay, for reliability and all. But according to your syllabus, remembering so many things will be very difficult. But at least you know what is that IPv4 header consisting of, and what are the things inside it will be there. Then protocol, name of the protocol has to be passed. That is also 8-bit. Error checksum, and we have seen that in error checking, we have this error checksum and all. Then source IP address, that is 32-bit IP address for the sender and the receiver also. Okay. Optional information like source route, record route, that can be that. That is mainly for the network administration will check out on this. So IPv4 header, when you explain any IPv4 header, you are supposed to explain of this version. Header version is nothing but IPv4 header length. Type of service, I told you that it is about delay, throughput, reliability will come. Total length 2 power 16, and identification. So in that identification, 16 bits means it's a unique packet ID. For every packet ID, we have this identification. And flags, you all know that when I'm going with this or whether it is a fragmented or not, will be that. This is a fragment offset 13 bits. If we are having a fragmentation from one level to second level and second level to third level of that. So when you see our datagram, it is divided into 3 fragments now. Again, my second fragment can be divided into 2 more fragments. So that all will be defined here. Then time to live of the packets. Then protocol, what protocol I'm using, header checksum for error checking. Okay, this is the source IP address 32 bits, and this is the destination IP address 32 bits. Now, we have seen this is IP addressing, and you have noticed how we have to look up our IP address in our Windows and all. So you may check, you may note down this. I try to upload this PPT by today to go with that, how we can see this IP address in our network. Okay. And I think ma'am also given about you the class A, class B, class C and all. So this is the same thing. You all know class A, how many address I can use it, ma? When you go with that class A for large number of nodes, and class B for medium number of nodes, and class C for smaller number of nodes, and class D and E are reserved. So when you go with this is around 16 million address can be used for class A, and class B 2 power 16. So 65,536 ID will be used. But when you go with class C, that is 256. So they will check, and they will see that see our start address and end address is also given. So when you go with that, our nodes, when you see that, we all under the class C only because it's a small node only. But when you see to that, here we can allocate 256 address. For example, in your home, you need only a single address or two more address, or else when you take the medium company and all, what is the problem now? They need only 50 address. So remaining 250 address will not be used. Like your concept of array in C. Okay, when I'm declaring my A of 100, that is the maximum in single dimensional array. Okay, and when you see to that, I'm using only 10 inputs only, remaining 90 bytes. That is, if you take integer, it is 4 bytes. So nearly 19 to 4, 360 bytes get wasted. So to avoid that, what we have gone with the topic of that, we have a static array and dynamic array there. So we have a dynamic memory allocations. So similar way, when I'm going for this kind of things, I can go with this subnetting. I think why I'm going and previously explaining, you have to understand where that subnetting is there. Okay, when you see to that, it's a small one organization. There they are need 40 for engineering, human resources for 20, sales for 20, and this is another thing, technical and executive management. So while dividing a single network into multiple small network, that is subnetting. Okay, class C, we have a around class C, we have around 256 addresses. Okay, class C, we have 256 addresses. And when I'm going with class B, we have 65,536 addresses. And when I go with class A, I'm having 60 million addresses. So to that, I'm using only this much of addressing. Now, I have to divide my entire network into small network. That is subnetting. Okay, I think this is the application told about the subnetting. Why? Because now this is get wasted. The remaining addresses are get wasted. That's why I correlated the same topic with the array. Okay, now, and in that we have a two method. I think fixed length subnet mask, variable length subnet mask. You all understand fixed length means, for example, it is 256 now. Definitely, we have a splitting of over 50, 50, 50 there. But when you go with variable length subnet mask, okay, variable length subnet mask means in this we have some more length. It's not a equal. Okay, when you see to that, here I have a one more length. So this is the variable length subnetting, and this is the fixed length. This is the fixed length subnetting, and this is my variable length subnetting. Okay. So I told you why we are applying the subnetting. What is addressing? Okay. Now, yeah, this is the class A. So we all told that 256 address, 65,530. So that's why it's for a large organization of a class A address will be there. But normally we all have using the class C, that is small number of nodes, and class B, it's for medium number of nodes. Okay, so 191 point, that is, this is my start address and this is my end address. Class D and class E are reserved, and you know class D is reserved for multicasting and class E is mainly reserved for experimental and R&D. So for that they are using the class E network. Okay. Okay. Now we all know this. You have to see how we are dividing now. I think how many bit, and 1 to 126, 128 to 129. And 192 to 223. This is the way my field will be decided. Okay, you just see to that how the address field. So I think this is the most thing. This is the 8-bit they will allocate, and here it allocates 16-bit, and this why it's allocate 24-bit. So when you see 24-bit, the remaining 8-bit only for addressing. So 24 plus 8, 32. So this 8-bit only for addressing now 2 power 8 only 256. Here 6 for size of the network now. The remaining 16 for address per network. So 16 plus 16 we have 32. So 2 power 16 address will be that. Here they allocate only size of the network bit is 8. So the remaining size is around 24. So 8 plus 24 32 bit. So 2 power 24 16 million will be addresses will be allocated for class A. So remember class A 16 million. Class B 65,000 and class C 256 address. That's why they have told you that number 1 to 126. Okay, how many bit we are allocating and all we were seeing. Okay, so when you see to that, this much of address range, this much of address range, and only this much of address range. So here when you see to that, I can vary from 255 0 to 255 addresses I can vary from, but here 128 to 191. You see that here 192 to 223 only 256 seems to be, but here 65,000 seems to be, here 16 million seems to be, and this is for class D for multicasting, and this is mainly for reserving like that. How can we say now it is for R&D purpose and all they kept the class E network. Okay, now we all know that how we have a network ID, host ID. So here they allocated only 8 bits and remaining 24 bits for address allocation. Here they are allocated for 16 bit. So remaining 16 bit for allocation. But here when you see to that 24 bit for network ID. So 8 bit only for developing the addresses. So that this is the way, but we all know class D and class E reserved. So this is the address range of class D and class E. So when you see to that type of casting, actually when you see this is we normally in all our IPv4 also we have a unicast, multicast and anycast. So I think I will go with this. This is for IPv6. Okay. Now you just see this unicast, broadcast and multicast. So how we are sending the message from single host using this IP address for unicast, broadcast, multicasting and all. So broadcast they normally use the class C network and casting. I told for that 1-to-1 is casting. That is unicast. Only 1 point to 1 point. Okay, and broadcast when 1 point to all the networks which is connected to the point. This is my broadcasting. 1 to all. Okay, all will be connected. Multicast means the so many thing will be there, but it will be only connected with, for example, this is broadcast. I told you 1 to all. This is 1 to many. That's it. So this is the unicast. This is broadcast. This is multicast. What do you want, Ma? Om? Multicast. So normally here in broadcast, we all know that class C network will be for broadcast, and you all know multiclass, class D ranges will be supported in the multicasting. But normally we all having this broadcast. So there we have a subnetting. There I can divide my network into fixed length or variable length, where I can do the subnetting for my IP address to utilize this address very well. Okay. You understand what is unicast, multicast?
Differ from each other.
Yes, ma?
Ma'am, how multicast and broadcast differ from each other?
Multicast and broadcast. So you understand that when you go with multicasting, very simple example, when you go with some live TV and all, or it may be the example wise how we can say it now. Live TV channels, live radio broadcasting, will be comes under the multicasting. So there we will get whether you have a connection group of nodes we have connected, we can receive in the multicasting mode. Is clear? Where we connected to that, that is multicasting. Broadcast, everything, everyone will receive it. Okay, I think this I will tell you along with in IPv6. Now you understand this is a unique cast. So source and destination where my packet will be delivered, source to destination, that is unicast from one sender to one receiver. That's all unicast, one-to-one transmission. So limited broadcast also, we have two kind of broadcasting, limited broadcast, direct broadcasting. Okay, so when you see the limited broadcast, when you see here, this is, I think, this is the best example. When data sent from one host to all the hosts. So for example, this will be the source IP address and this will be the destination IP address. So depending on the destination IP address, you all understand that according to the wherever my receiving ID will be there, my packet or will be sent to that respective ID. So that you all that all once in destination. This is the way. When you see to that 255.2, 55.2, 55, all in decimal notation, and this is all in my host address. So where I want to send to the limited address only, this is limited broadcast. So broadcast means one to all, but depending upon that, my host want to communicate it to only this much of there, I will mention that still comes under the limited broadcasting. And this is all about direct broadcasting. So, okay, direct broadcasting in sense, you understand that here again my source IP address will be there and a destination IP address there. So when my network, it will broadcast to all the network which is present in this. So when you go to the previous diagram, this is my network is there, but in the destination, I don't have, I have a, depending upon my destination only, my packet will deliver. But when you go to that, the network which is there, all my packet will be delivered to that particular network. That will be the direct broadcasting. So limited broadcasting, even though in the network where I want to send that particular destination ID only will be present. But direct broadcasting means all the destination ID it will send. Okay. And you all know this is the multicasting. So I think consider the figure. Okay, A send a multicast packet. So what are the group nodes? You have asked you the difference now. B, C, D, E, F. Okay, in that. But when you see this is the entire network, I want to sell only to this type of group of nodes. So here automatically class D will be used to send to the particular destination, and I will receive only send to that B, C, D, E, and F. That's why I told you that it is like a live TV, and we all have a kind of live TV. Very particularly, if we have subscribed that, we can able to access that. So it will send to that particular whole network, but this particular IP address only, it will send the packet. Okay, it will not send to all. So that how my IPv4 will works for unicast, multicast, broadcast. Under the broadcast, I have a two things: limited broadcast and direct broadcast. Have you understand this? Have you understand? Sagar, have you understand this? Where I have to send to my group of nodes. Yeah?
Yes.
Yeah. Group. If you subscribe that channel, you got receiving that packet now. There my source IP address will send to my destination IP address. So there they were employing the class D. So class D, we all know the class D multicast address ranges is vary from. So how many bit they are allocating? I think when you go to this, the multicasting, how many bit they are allocating? We all know class A, class B, class C, class D address and all. So this much of address is allocated to do the multicasting. So group address only, it's a unique address only. we will send that particular host to destination. The group of node only will receive it. Okay, now you all understand we have a IPv4 is also supporting unicast, broadcast, and multicast. And I told you that IPv4 we having a shortage, address shortage. I told you about the subnetting. So it have a two more techniques to divide my address, and I can give it for another network. That is, one is CIDR, classless interdomain routing, and another one is network address translation. NAT. Through that, I can shortage my address. I can give to more users. So for that, address shortage is used. One thing we have seen that subnetting. So the two more techniques is also that. So you all understand that this is all about your IPv4. Okay, you all understand in IPv4. Yeah.
How address shortage can occur in IPv4?
Yes, ma.
Ma'am, how address shortage can occur in IPv4?
Can't able to hear your voice. Once again, wait. Now louder, please.
Ma'am, how address shortage can occur in IPv4?
At this
Address shortage, ma'am. How address shortage will occur in IPv4?
How address shortage will occur. That's why I told you. So you all understand that address shortage only you asked, Sagar. Am I correct?
Yes, ma'am.
Yeah. So address shortage in sense, that's why we have gone with this kind of address. So that's why we are saying that using subnetting and using that CIDR, NAT and all, we have used, and you all know this IPv4 and all, the IPv6. You all imagine we are using some 2^32 addresses in IPv4. Okay, so around some 4.5 billion, I think so. You see our differences. 4.3 billion addresses. IPv6, when you see to that, using more number, there is 128-bit IP addresses there. 79.10^28 addresses will be there. So that's why in that the shortage will be recovered from IPv4 to IPv6. Is clear? But when you go with some older systems and all, we have IPv4 only and supporting document. In some other system, it's not supporting IPv6. And in Windows 11, Windows 10 and all, we can go with IPv6 also. Okay, but when you, I think now I have shared our own network. In our college network, I have shared you this information, but you all understand, I cannot able to see this. You see the change adapter settings. We have a broadband connection only. So when you see that, I have a property. See, this is my LAN, local area connection. So where I am connected with my EEE server, and you all know that this is my network interface card, Realtek PCI. When you go with that, this is my network card interface. And here I go with my properties and sharing networking. So you just see Internet Protocol version 6 and Internet Protocol version 4, TCP IPv4 as well as TCP IPv6 is also nowadays available in all our system. But when you go with our home and all, because our institution is a very large institution, that it's showing both. But when you go with the home and all, it is showing Internet Protocol version 4 only. There they provide the subnetting and they were giving to our house. That's why I go with the class A, class B, class C, and all. Okay, so I think most of our that 1 to 98.168.1 point. This is the way the addressing will be there. That is used for further reserved purpose. Also, they kept it. Okay. Network address translator also there. So all this are to reduce the address shortage. We have this IPv4. So what is your answer now? That will be done by IPv6. So you all know this 1999 or 1998, they deployed the new version of the internet protocol, that is IPv6. So nearly 120-bit IP address. So imagine 2 power 128 internet addresses in total. So there you have a 2 power 32 addresses, but here we have a 2 power 128 addresses. You all know that is 128 bit. So in that 128 bit, how many fields are? 1, 2, 3, 4, 5, 6, 7, and 8. Okay, you all know that each bit you having a 16. 16 into 8. We all know that totally I will get 128 bits. So first column, second column, third, fourth, fifth, sixth, 7, and 8. And one more thing, IP address is separated by dot now. IPv6 address is separated by the semicolon. So we all know 16-bit, how I am saying now, 3 FFE means what? 3 FFE, how will you write? 3 is nothing but 0, 1, 0, 0, 1, 1. F means what? 1, 1, 1, 1, 1. Another F, 1, 1, 1, 1, 1. E, 1, 1, 1, 0. So totally how many bits? 16 bits. So 16, how many segments are the 8? So totally 128 bits. I think the network address problem will be resolved using this IPv6. Yes, Sagar, you got your point?
Yes.
Yeah. There we have a 32-bit, but here we have nearly 128 bits. Okay. So this is the features of IPv6. The thing is hierarchical addressing and routing infrastructure and quality of service and an idea protocol for neighboring node interaction. These are the some of the features, but this is the main feature. What is the first? Now this is the Sagar question. Whether any shortage in IPv4, we have a larger address space in IPv6. That is, and no more need of, that is how we told now the network subnetting option is not available, not needed in this IPv4. Simple header, not like that. There we have a version, header file, type of service, identification. It's not like that. It is a simple header file where we can understand that easily and increase the router efficiency. Because if we are, every time the router, we all know that it has to look up the ID and that which is my neighboring ID and all, how my packet has to be delivered. But this IPv6, the router can identify by this simple header. This is based address hierarchy. Okay, no more broadcast. Okay, stateless auto configuration. Then built-in support for mobile IP, security, okay, rich transition features, easy IP addresses renumbering. We all told you that when I'm taking my 32-bit, I told you 8 plus 24-bit, and that 24-bit only for deciding the number of addresses. Then 16 plus 16, that 16 will decide. Then when I'm going with that 24 plus 8, so that is not like that, because this will have each ID have a unique address there, so I can easily identify. Capability to have multiple addresses per interfaces. So these are the main features of IPv6. What is your question on large area address space that will be having in IPv6? Okay, and you all understand. It is very simple thing. You may understand that how that 128-bit will be there in a format of IPv6. Okay, version, PRI, flow label, and every time when you go with the next header and all, we get around some 32 bits. Okay, so when you go with that version, 4-bit sequence, whether we can identify IPv4 or IPv6, there I can identify traffic. Okay, the field is similar to the service field. Okay, how the traffic congestion. You all understanding now? in distance routing algorithm or link space routing algorithm, we were saying that it will find out the minimum delay or low delay and all. Na? That is all because of this traffic class. So where how I can send my data, or else if there is a heavy traffic congestion, automatically my packet will be discarded and all. So the flow label, okay. The flow label is for memory functioning and all. So reordering the packet, which packet has to deliver and all, that will be the flow label. Payload length, okay. So payload length is around 16-bit. Okay, that will indicates that how many data will be in that particular file. We all know that it is allocated 16. The payload length will be around 2 power 16, 65,535. Okay, and the next header, that is the extension header, because we all know from application our network layer to transport layer, we have in transport layer we have UDP and TCP protocol and all. So how it is compatibility to work with IPv4 and IPv6, where I have to transmit that and all information will be in the next header. Hop limits. Okay, we are saying 1 hop, 2 hop and all, no? Minimum hop. So you are saying maximum 255 hop will be there. Apart from that, if more hops are comes, automatically it will discard. And source address 128-bit and destination 128-bit. So you all understand that here, what is the, when you comparing with my IPv4 header and IPv6 header, version is also there. Traffic, instead of traffic, we have seen that there are also low delay, throughput, reliability and all, that all will be in the traffic. But there is no fragmentation here. There is a flow label, they are saying that which will be first, which will be second and all. So the fragmentation detail is not that, but instead of that, we have a flow label. And here they have mentioned the payload length, that is also available. The next header, where my packet will transfer from data link layer to transport layer. That next header protocol has to be defined there. Hop limit, how many hops I can transfer from one router to another router, maximum 255. And this source address 128 bytes. And this destination address also 128 bit. So totally we have mainly, when you see that IPv4 is 32 bit and IPv6 is so we can go with that. 128 bits source address. So there we seen 32 bit and there 120. And this is the difference between the IPv4 and IPv6. So here when you see to that, mainly they are saying this IPv4. I think mainly if they ask any kind of difference, you may write it IPv4, IPv6, and it's separated by dot, by semicolon, and it all contains binary bit, but we know how to write it in decimal, and it all contains hexadecimal. Address type, you all know unicast, broadcast, multicast, and here unicast, multicast, and anycast. Okay, address masking definitely needed in address masking is needed. Why? Because now we are doing subnetting and we are doing that all, but it is not used. Unique address will be there. You just imagine number of header files, 12. Okay, and here it's 8. Okay, and the length of the header file 20, and here 40. So length of the header file, it's get increased automatically. It increase the address capacity also. And here checksum field is there. Here no checksum field. Okay, and when you see to that, it supports class A to class E. But here unlimited number of IP address is there. So there is no class recognition in IPv6. So while we are talking about IPv4, you have to suppose to explain about IPv4 header, and then you have to explain about the address types, and you have to explain about the number of classes. All this will be supported to that. Okay, VLSM that we have seen, a configuration is also that. IP address and routers must be assigned, and here configuration is optional only. Then VLSM that we have seen, variable length subnetting, that is definitely in IPv4 it is needed, but it is not needed in IPv6. Fragmentation, I told you that done by sending and forwarding routes. done by sender. That's it. That's why I told you in IPv6 header file, we are saying that rearranging the packet is there, but not in the fragmentation is not being supported in IPv6. Routing information protocol. You all know supported by the router daemon, and here you have asked you about RIP does not support in IPv6. It uses the static. I think on that day you have asked about that routing internet protocol that is not supported in IPv6. It have a static routes only. Okay, then you all know it's a manually and it is auto configuration, because network configuration we can able to configure it because we are doing the subnetting, so we can able to do that. Okay, here SNP is protocol is used for system management. It does not support. Okay, mobility and interoperability. Relatively constrained network topology to move restrict mobility and interoperability capability. Okay, and DNS record. You all understand. I think it's more specific there. I think we may explain it. Quality of service is good. Mapping is good, and IIP to MAC resolution. This is broadcast ARP and this is a multicast ARP. And what are the domain name service records are there? Pointer records, in address, DNS domain and all. And these are again same thing, pointer address. Instead of in address, we are having IP6, IP6 ARP. Okay, DNS. Okay, domain name service and mobility and interoperability. So here IPv6 provides interoperability and mobility capability that are embedded in the network devices itself. I told you that's why IPv6 when you go with that higher range of devices only, it is supporting that. Okay. So this is one of the most important difference between the IPv4 and these are the popular well-known IPv4. Just they will tell about this IDs and all. Okay, I think it's not easy to remember and all. You just have through this. ARP, so address resolution protocol. So I think while we go with ARP, I will tell you what are the protocols in the internet protocols. What are the protocols we have seen, ma? Here, this is in your syllabus. When you go with my syllabus, I have IPv4, IPv6. Here we have a two things, IPv4 and IPv6. That is covered today. Okay. ICMP, Internet Control Message Protocol, IGMP, ARP, RAP. So I think around 6 internet protocols are there. So using the 6 internet protocol only, this entire networking protocols we are going to see. So today I covered 2 things, okay, IPv4 and IPv6, and this ARP is for address resolution protocol, and this is for to know the physical address. Okay, I think some 8 more minutes is there. ARP. What is ARP, ma'am? Address resolution protocol. Okay. It is mainly used to find out the hardware. I told you the network interfacing ports are there to identify this MAC address to a device from an IP address. Okay. And it is used to where I want to communicate and all. Whether, for example, Ether network, while I am identifying my IPv4, how I have to see the IP address for Ether network and IP address for Wi-Fi network and IP address for that LAN network and all. So the similar way, before sending the packets, it will communicate to that particular local area network. There, what will be the physical address will be that. Okay, so the sending device use ARP to translate the IP addresses to MAC address. Okay, you all understand? Address resolution protocol will translate to IP address and IP address to MAC address. Because we told you that ARP is mainly used to find out the hardware address, that is MAC address. So this is the translation. So that what it will translate now, IP address to MAC address. That will be translated by the ARP. So the device sent ARP request message containing the IP address of the receiving device. So you all understand that, all know sending and receiving, all that will be routed from my host to destination path, and which will be my receiving device. That request message will be that ARP will send. ARP will send the request message containing the IP address of the receiving thing. So, okay, ARP packet send the broadcast address. So you all understand FF, 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 FF. We all know. We all this values 251, 2, 3, 4. How we were representing this. This is Ethernet broadcast and this is IP broadcast. So you all understand it is requesting the receiver whether it will receive the data or not. So when you go with my broadcast is Ethernet broadcast, I have 3, 4, 5, 6 fields, and here I have 4, and you all know this is, we told that if I use semicolon, that is for IPV6 and dot for IPV4. So you just see how it is working. So ARP request, ARP request, ARP request, ARP. So just it will communicate to convert the IP address to MAC address, and it will send the request to the host which is nearby the router. And when it got a reply, at that, for example, it is sending the request to host B, host C, host D. But when you see that while it's sending the request, it is not getting any acknowledgement. From host B alone, it is getting the ARP reply. Okay, once it get the reply, automatically my packet will be forwarded to host A to host B. So the ARP protocol, the address resolution protocol, the purpose is my sender will convert the IP address to MAC address, and that MAC address is my hardware address. And once again, it has to understand that it will send from my host to different host which is nearby from the routing, and that particular host, which host is replying to that particular destination ID only, it will transfer. Okay, so the same thing, say what I have told you, that is given in this point. So it is communicating to host B, host C, host D and all. So there my host B only replying to me. So automatically host A have enough message to send the signal to host B. Okay, so that is ARP. ARP is defined, but again when you see to that, we have 3 more protocol has to be covered. When you see to that, ICMP, IGMP, RARP. So this we have to discuss in the